Good afternoon and welcome. My name is Keith Schultz with Prolim. I'm a CAM Applications Engineer, and today we're going to be looking at the new ONMachine Probing module in 2306. This is going to be an overview of use, and we're also going to look at getting some additional features downloaded in NX from PostHub. So we're going to look at the Siemens Cinemeric side of things. There's a Fanuc version. It's a little more involved, and thus we decided to give it its own showcase at a later date. So this is going to be a brief informational presentation to let you see the new interface, and we encourage you to download and play with this yourself. So what we're going to talk about is what is OMP, ONMachine Probing, what cycles can I use, and how do I use it. We're also going to talk about setting up. That includes downloading the OMP cycle package and installation of the post-support layers. And something I'm very excited about is the new adaptive machining. It looks like it's going to expand on OMP and take some more of the work out of it. And I'm really excited to see what NX has for that. So what is OMP for? So some of us has probably heard the term, and most manufacturers have provisions for probing. Automated tool setting is now the standard for setting our tool length. ONMachine probing is definitely a key to success in an automated factory. So while NX is not new to probing operations, this new module will help you streamline your programming of your probing operations. No longer do we need to generate each move separately. So what is OMP for? So we've probably used it before at the machine for setting up workpieces after clamping and correcting R0 on a tight part in blank envelope. We can use it for the automatic control of workpieces in the machine during the machining process and correction of 0-point offsets. So why am I going to use ONMachine probing? So by digitally expanding your machine shop, you can become more competitive, efficient, and profitable. Converting your machine shop to a digital process provides powerful advantage. You can reduce your turnaround time by connecting people, equipment, and the entire process with a digitized process. You can deliver high-quality parts on time by predicting and eliminating errors by using your digital twin of your part, resources, and the entire process. You can also expand and grow your business by implementing new automated technologies such as ONMachine probing. Probing critical dimensions in our workpieces can reduce our scrap rate by allowing us to measure and adjust our process while still in the machine. So a digitized workflow part can be probing our tool before we start machining to check for breakage and upset our wear. We can then probe our stock to check for errors in setup, whether it be loaded by an operator or a robotic loader, and to make fine adjustments to our work offsets. After machining a feature, we can probe critical dimensions and adjust our process and have an automated rework process. Or we can write logic to alert an operator or manufacturing engineer to intervene. In the long run, we can also capture all of this data and follow trends for tool life, and keep our process under predictable control. So instead of switching to a backup tool when breakage is detected, we can determine after so many parts that we need to start switching to our backup tools. So let's talk about robot tendency CNC machines. So a crucial part of running a robot tendency machine cell is probing. Why is that? Well, if we want to be able to run lights out, our process needs to be robust, and we need to ensure that our part is correctly loaded. So being able to check that the robot and machine work together to load our part correctly can save us costly errors and make our automated cell more robust. So what are ONMachine probing cycles? So probing cycles are special subroutines for solving measuring tasks. Parameters are used to adapt them to the specific measuring task. Probing cycles are generally valid and are not limited to a specific touch probe manufacturer. Measuring cycles support triggering touch probes and are not intended for measuring or continuous touch probes. So what can I measure? So if the probe can get to it, we can measure it. So there's NX has options for measuring pockets, bosses, ribs, planar surface. You can also see up here that we also have options for measuring a linear vector based on 2 pockets. So we can modify these cycles in a user-friendly operation dialog. So how to use ONMachine probing? So a whole range of cycles are provided for the programmer. But unlike what you might expect, the programmer does not have to select the cycle and then select the geometry. Instead, the user gets a suggestion after selecting the geometry as to which cycle would be best suited for that selected feature. So based on the defined geometry, possible measuring cycles are then suggested, and the operator only has to adjust the parameters they would like to use if they're different from the default settings. So let's take a look at this module. So here I have a workpiece set up in a simulated mill, a little 5-axis. We also have a couple extra accessories on there. This part is, I believe, a windmill hub blade. It comes actually as an example part with the downloaded packages when you go to PostHub, and it's a really great part for practicing processing a part. So how do we use this new cycle package? So let's go through the first part of our setup. Is that I wanted to just show that I am using the master model process, and we have our workpiece defined, our blank defined, and we'll go ahead and define our check geometry. Not that we have to worry about running into it. Okay. We've also have our material defined as well. Next thing you might have to do, if you haven't already, is create a tool. So if we want to create a probe, we simply come into the type and go to probing and select a probe. Now we can either make our own probe, we can use a model, or we can retrieve a tool from the library. So in the library, the probes are listed in the solid type under probe. Let's say OK and see what options we have. Right here, you will see a few of the standard probes that come out of the box with NX, such as this probe diameter 6 millimeters. I believe this single tip, and I think this OMP2. All of these RMP2s got downloaded when I was downloading some of the Fanuc cycle packages. But they're all very useful to have in your toolbox. I've already created probes, so I don't have to go through that. All right, I'll show you that in a minute. So look at our tools here. You can see I have that probe D6 sitting in my pocket, in that first pocket. And that's what I'm going to use to do the rest of these operations. All right, let's get back over to our program order view. I have a few operations in here already, and I also have a mill control dialog in there to theoretically set my G54. And the first thing we're going to do is we're going to find the top of our part in Z to start setting up our work coordinate system. So to do this, you simply create operation. Probing type is already selected. I'm going to show you where it is. There's probing. We're going to use our program group of probe work offset. As you can see, I have quite a few program groups set up here. We're going to be using the probe work offset, and our tool is going to be our probe. Our geometry, we're going to stay with G54. I want to show you that I have a G54 as a child of our workpiece. And we're going to use a method called OMP stock. You'll see that I have 2 additional methods in here, OMP find and OMP stock. I think it's worth mentioning that right now. Let's go ahead and look at that. So let's look at our methods. Let's look at our methods. And you can see I have an OMP stock and an OMP fine. So what you can do with this is you can set up your feeds, and you can set up your tolerances. And what you do with probing is basically you set your tolerances based on what kind of operation. You will have a very tight tolerance for you when you want to set up your wear offsets for your tool. But when you're just finding your stock, you might be able to go with a larger deviation. So that's what that is. All right, let's get back into that operation. We're going to do that probe operation, okay? So we have all of our parents selected. We are in our probe work offset program group. We have our probe, our geometry, and our method is that OMP stock that I created just for this. Now I'm going to name this how we're using it. And we're going to use this to find our Z. Sorry, my chair's a little squeaky. All right, so the workflow for these probing operations is pretty good. Let's see. All we have to do is select our probing geometry. The cycle is going to show up in the cycles, and then we go to our probing parameters. Let's see how that works. So I'm going to select the top of our stock. Select OK. And you can see that we immediately get a few different cycles that we can use based on that geometry we selected. So since we're just finding our Z, I'm going to go ahead and use this numeric cycle 978 set single edge distance. Once that's highlighted, we can come over here to probing parameters. As you can see, everything's locked out right now. We're going to go ahead and unlock all these and set them to user defined so we can play around a little bit and see what's in here. Bear with me. Here we go. All right, first thing you'll see here is a measurement point. And you can't see very well, but there actually is already a toolpath generated, but at the work coordinate system is kind of getting in the way there. And I'm just going to select a spot on the part away from the center just so we can see what's going on here. All right, so there's a toolpath that's quickly generated automatically as soon as we select our method. So let's look at our offset target. So we can measure only, and we can apply logic to that measurement. We can select work offset, or we can set our tool offsets. So right now we're going to use our work offset. All right, once we select work offset, extra options show up. Let's look at those. So we have the option of either our active work offset or all of your standard work offsets in a cinemeric environment. And we can select between fine and coarse, and we can set off offsets. This DFA and TSA, tool safe area, have to do with our length of our approach. So right now I'm just going to set it to work offset and G54 and fine. Select OK, and we can generate. And there's our toolpath. You can see it's found its way into our program tree. So now let's do another operation. We can do, if this was a square stock or even round stock, or doesn't really matter. We want to find the middle of this stock because we want to make sure we're on the center of the stock. So we're going to do another operation to find our X and Y. Another check of our parents. We're at probe work offset, tool of our probe, G54, and our method is that method that I created. I'm going to name it find XY. Okay. So once again, we go through our workflow by specifying the geometry. In this case, it's one surface. If it was a square stock, you'd have to select all 4 edges. Now that we've done that, we're going to get some options. So we can see that first option here is cinemeric cycle 977 spigot. So this measuring variant is used to measure a circular spigot on a workpiece. The diameter is measured and the center point is determined. So that's exactly what we want. That's what we're going to use. So you can see the toolpath has already been generated or shown here as a preview. And we'll simply need to make some adjustments to the probing parameters. So we're going to select that button right there. And once again, we have that same window. So let's unlock some of these. And you can see in the measuring methods, I didn't cover them in the last operation, but we can align the probe as well. But we're using a standard measurement method. And we're going to do the same work offset. We're also going to set it to G54. And we're going to, measurement point. I almost forgot. Measurement point is going to be how far up or down the workpiece the probe tries to go. And once again, the DFA and DZ and TSA, tool safe area, are going to determine the length of these paths here. I'm just going to click a point on the side that I know my probe's going to be able to get to it. And there we go. Select OK and generate. So we have our two probing operations. Now remember before we talked about having a robot load your part in your vise. And we might need to figure out if that part has been loaded correctly. So we can use the Z and the XY to help us determine that. But let's create another operation that's really going to help us out. Check our parents. And we're going to check the level of our part. So in this case, we're going to select the top of our part. And we're going to select our 3D align plane. So this can use to be determined and correct the angular position of a three-dimensional inclined plane. So you see in the corner we have a couple of alerts that already come up saying select all these measurement points, and that's in our probing parameters. So we can clear these alerts fairly quickly by specifying some points. I'm going to select 3 points on the face here. You cannot automatically cycle through these. You have to select each one. And I'm going to select the last measuring point. There we go. You can see a preview of our toolpath already. All right, now let's look at the inherited parameters and changing them user defined. Let's see what we have here. I think we're going to only use measure only because, like I said, if we're going to use this just to apply logic and alarm out and make sure the machine doesn't continue on with the process, that's a very good tool. But you could also use this for your work offset, and maybe you needed to tilt the table. If you were to tilt the table and use that to adjust your work plane. Right now we're just going to measure only. I just wanted to show you how that worked. I'll generate that. Select OK. All right. So for the next process, we're going to show you how you can probe a feature that you've machined and use that information to go back and write to your wear offsets. So we're going to come down here and I'm going to pre-select this finish program. We're going to create another operation. Before I do that, I need to hide my stock. There we go. All right. So our program is going to be in finish, and we're just going to change our method to OMP find because we're going to be writing a tool offset. So we want that to get the closest tolerances we can. All right, select OK to that. Once again, I'm going to pick a place to measure a critical dimension. Let's say we're going to say it's this hole right here. Select OK, and once again, we'll get these options. So like as you've been able to see, when you hover over these options, it tells you what they're all for. So we can measure a hole from 4 points, or we can measure a circle segment. So since we have a complete hole here, we're going to go ahead and use that cycle 977. And you can see the preview toolpath has already been generated. All right, so let's jump into our probing parameters. All right, I'm going to unlock some of these. And what we're going to use is the tool offset. All right, so this TR is the tool you want to set the offset to. And in this case, for that particular hole, we were using a 5mm end mill. We have our D diameter, and we also have a selection for adjusting either our geometry or our wear. So I'm going to select wear for this. And the D value might depend on your controller. You can either use, some controllers will only write offsets to whatever tool is in the spindle, and that's going to be diameter 1. Or you can write it to the tool itself, but that all depends on your controller. I don't have a Cinemeric machine with me here to test this out, so I'm just going to go ahead and leave that at a 1. But I think you understand how it works. So the last thing we're going to have to do is, you can see we're a little bit high on this feature here. So I'm going to go ahead and use this with this measuring point already highlighted. I can come down here and I'm going to move that down a little bit just to make sure we get a good measurement. All right. So before I get out of this, I don't want to forget something else. We have a tolerance allowances in here. Let me unlock that. Check that box. And you can see we have a tolerance upper limit and a tolerance lower limit. As you can see, that tolerance is a bit widespread right now. So let's just go ahead and change that to something a little bit more realistic. There we go. Select OK and generate. So that's how you set up all your probing operations, and I hope you found them a lot easier. Another thing we want to talk about is some of these mill control operations. And some of these operations you are going to have to write logic. But luckily, let's go ahead and create a mill control operation. And we're going to go into the notes. So this is where you can put your logic. But Siemens NX has done something great, is they've given us actually like a library of text that we can use. So you can see those probing templates are located within the probing cycles and the templates. There's a Cinemeric and a Heidenhain as well. So if we need some kind of logic, NX has made it a little easier for us because they can help us out with setting variables and things like that. So now that we've created a few different probing operations, let's show you how the simulation works, just like any other toolpath. Let's go ahead and display our in-process workpiece. We have our program group selected, and we can just simulate from the toolpath animation right here. There's our us finding Z, finding our X and Y. I'm going to speed this up a tiny bit. And the next cycle you're going to see is that 3D align plane. There it is. So like I've said before, We can do many different things with the measurements that we take. We can either use logic, we can set work offsets, we can alarm a machine out if a part is not properly mounted. And these arguments are located, that we were just looking at, are located in the UGI CAM probing directory templates. So I had said something about adaptive machining at the beginning of this webinar, and I'm kind of excited about it because NX only gave us a little teaser. So we saw how the probing currently works, and Siemens is trying to get big, is really leaning into Industry 4.0. And this module looks like it's going to take some more work out of the process and take care of those arguments for us. I'm not sure yet, but this will be a huge benefit for digital manufacturing. So if you don't currently update your NX version, you might want to consider upgrading when this module comes out. And of course, we will post about it when it is established. So there's a few things we need to do to get this to run correctly in NX. So updating cycles, the out of the box ONMachine probing control cycles released in the 2306 and later are under continuous maintenance, and therefore they're being developed at all times. So there's a possibility to download this content via NXCAM's post hub, and that will update the existing cycles when needed. So basically, they're letting us know that they're continually working on this, and there's going to be more that comes out as it goes on. So for the post processor, so in order to obtain a machine cycle via the post processor, it's necessary to extend the custom post processor. So for this purpose, an example is available on Post Hub, which can be added as a layer based on the post configurator technology. And that'll help you generate the required output of the machine cycle. So the example is provided on the basis of a non-tailored post processor. So it might be necessary to make adjustments to ensure correct output. So always test that code, or always run it safe first before you go full send, okay? A post processor is not part of the delivered solution, and the implementation is not part of the probing solution. For this, please contact your supplier or your internal specialist department. It's going to involve downloads, environment variables, and pointing NX towards the post support layers. So for machine simulation, so in order to be able to simulate any machine cycle via the machine simulation, you're going to have to extend the existing CSE simulation. For this purpose, an example is available on Post Hub, and these are free, of course, if I didn't mention it before, which can be added as an extension based on CSE technology. That includes the required subroutines in order to verify the desired simulation of the machine cycle. An example is provided on the basis of a non-tailored simulation, and it's going to be necessary to modify in order to ensure that the simulation is correct. They're just another warning, right? So how to get it on Post Hub? So we need to get into Post Hub to download the CSE simplified probing cycles, and we're going to price this in the location of mock resource library machines, installed machines, whatever, right? We want to download the ONMachine probing post layer. We get there by simply typing Post Hub in the search bar. So if you don't know where Post Hub is, all you have to do is go open your search bar and type Post Hub in the search bar. You're going to have a Siemens sign-in, of course, for that download to occur. And once you download, you will need to extract the zip file to your install location. So one really great thing is all of these files come with a folder called documentation. And in that, you'll find nice little things such as examples, that part that I just showed you, that wind turbine hub, and that they're all included in a nice handy PDF. So there are two ways to get the expanded cycle package installed, for instance. So we can either use a script that Siemens has included within the unzipped file. It's called ONMachine Probing installation.bat, or we can manually move the files for all these expanded features. And a special note, So if you're trying to use that script to automatically disperse those files into the correct locations, and you have a file path like I did in your installation, such as C/program space files, so that space is going to be a problem and that method will not work. But if you can use it, it's going to save you a little time. And that procedure starts with generating a log file and copying and pasting that log file into the folder called script. Then when you double click on that installation.bat file and follow the on-screen text, it's basically going to just place those files where you need to. So I hope you've enjoyed this webinar and this first look at the Siemens probing cycles. And I hope you come back again next month when we start talking about the Fanuc version of this. Thank you from Prolim and from Ohio, and hope you have a great day.